All right. Sorry, here we are. Yes, I know this was all last minute, but I didn't want to take any chances coming in today because it might have been bad. What we're going to do today is the solutions to the sample midterm, which we just finished the chapter 8 problem set, so we can do this now. And when this is done, I think we'd already decided to have our test a week from Thursday. Let me go get a calendar open here. This way, because this might take more than one class, and we don't want to rush. Let me just open up. Today's the 3rd. Now this is strange. Look at this. I asked for April, and some of these are January. Okay, here we go. I was hoping to make it a little bigger than that. Okay. Here we go. All right. So today's the 3rd. I think we can probably do our test. Today's the I think the 13th is soon enough. We just have to be a little careful because the finals are coming up behind that. So what we're going to do is, as soon as the sample midterm is done, we're going to dive right into the new material, which is chapters 11 and 12. And then, because our final exam, I believe, is Monday, the 8th of May. So our very last day is, I think, Monday, the 1st of May. So, we got a few weeks left, but, we don't have all the time in the world. So I thought what we could do is finish this up and then have our exam on the 13th, just chapter 8, that is. Okay, and then we'll just carry on from there. Now, of course, since there's only one chapter on this test, that means that the sample midterm will be similar to what we were just doing with the problem set, but it's all good practice. I'm sure you'll agree with that. And so what I'm going to do is, when we're done, of course, I'll post the solutions as I always do, but today there's also going to be a video. And so if you missed something, or if anyone who was sick today, you can go back and watch it. Now, the only awkward part is that, I tried this before, especially during the COVID. You probably are aware that a couple of years ago, all our classes were online because of COVID. And at that time, it became apparent that Moodle, for whatever reason, isn't really set up to store videos. It does fine with documents, but videos it has a problem with. So they're going to end up in my YouTube account if you want to watch. And so I'm sure you all know more about YouTube than I do, but well, as far as I know, all you need to find it is my name, but my official name on YouTube is Dr. ACA. It probably says it here, and here it is, Dr. ACA. Okay, so that way you can find it. Now, when you do get here, what I've done is I've set up a series of what are called playlists, and I'm sure, again, you're very familiar with this, one for each of our classes. So that way, when you go in to look for it, you can have trouble finding it. Okay, so that's what I just want to let you know. Now, everything in here, all the videos that I've recorded over the last years are in here. If you want to watch them, you can feel free, because they're all publicly available. But mostly they're other math courses, but not all of them. So if you find something fun in there, go right ahead and watch it. You never know what you might find in there, but it's mostly, math courses, economics courses, things like that. All right, well, enough of that. Let's get to it. So now, of course, we usually start in any exam. We usually have a handful of what are called fill-ins or short answer questions. This is where we can find out if you understand the basic concepts without having to necessarily do a lot of problems. So, for example, an annuity, a stream of equal sized annual payments. That's technically what an annuity is. Now, sometimes we use, as you know, the annuity formulas for monthly payments. And then technically, I don't think there's a formal name for monthly payments. We tend to just call it a monthly annuity. But the word annuity itself implies annual payments. But having said that, the most important detail is that the payments are all the same. That's the most important part. If they are, we can use our formulas. If they're different from each other, then we have to do something different. Okay, so the formulas that we've been using depend on those being the same exact sizes. Now, simple interest is, this is interest paid on principal only. Or if you recall, principal is the amount you either borrowed or lent. So if you put $1,000 in the bank, that is our principal. Whereas compound interest, this is interest on interest. In other words, as your account starts to accumulate interest, any further interest payments will be applied to both the original principal and any interest you've earned in the meantime. And so that's what this is. Now, these two interest rate measures, APR and EAR, are based on these same concepts. APR, which stands for annual percentage rate, is based on simple interest only. Okay. So that number tells you how much simple interest you're actually paying or earning when you set up an account or borrow money. Now, the EAR, on the other hand, is more involved because it incorporates both simple and compound interest. And so that means that this is really the more relevant of the two measures. We need to know both of them. But this is the one that determines how much you're actually earning or paying. Okay, so this one we say is based on both simple and compound interest. Now, okay, so as we just discussed, if you're keeping your money in a 5-year CD, certificate of deposit, remember that's an account where you leave your money at the bank for a fixed length of time. And in exchange for that, you get a higher rate of interest. It's a great way for people saving for their retirement because they know they won't be touching that money anytime soon. And so they can take advantage of that by putting their money in one of these high yield accounts. But if you do need the money back, you have to have an incredibly good reason for it. What will actually happen in practice is that if you ask for it back and you don't have a really good reason, like you need to pay for an operation or something, they'll give it to you, but they'll charge you a huge penalty, which will not only wipe out all the interest you've earned, but probably end up costing you money. So you really have to leave it there for the full length of time. But anyway, EAR in this case is the appropriate measure of how much you're actually earning. Now, this is an interesting question. It turns out that when n equals 1, APR and EAR are the same thing, because that means that there's no compounding. So it's just a special case. That is the only time that they match each other, when we have annual compounding. And we just make a note of that. Okay, so now I'll tell you what, when we get to that formula, I'll show you why. Actually, what the heck, I'll do it right now. If you recall, and we're going to get to this in a little bit anyway, just remember EAR equals 1 plus R over N to the N minus 1. Now remember, R in this formula is the APR. N is the compounding frequency. I was leaning on the wrong thing for a second. So you can see algebraically that if you let n equal 1, and look what happens. Whoops, wait, sorry, I wrote the wrong thing. Let's try that again. If you replace all those n's with 1s, here's what ends up happening. Now, remember, we define R as APR. So algebraically, if n equals 1, then the two will be the same. Okay, that's all that this is referring to. Okay. All right, so other than that, if, and I'll just add this here, although it didn't ask, as soon as n goes above 1, then EAR will always be greater than APR, okay, because of the compounding. Okay. Now, as compounding frequency increases, what happens to the simple interest on a deposit? The simple interest is not affected. This is kind of a trick question. Simple interest is not affected by the compounding frequency. Now, if you're not sure, just remember the formula for simple interest is, this is just a demonstration of why that's true algebraically. And if you notice, n does not appear in this formula. And so therefore, you know right away, well, that means that n doesn't have any effect on simple interest. It is entirely based on principal, the rate of interest, and the time. So therefore, the answer is it does not have any impact on the simple interest. But on the other hand, the opposite happens with compound interest. As the compounding frequency increases, which means n, that is. Just make a note of that. Increases, compound interest increases. Okay, so that's where the increase is coming from the compound interest. Okay. Well, all right then. So now for a deposit of $10,000 at a rate of 2% for 2 years, 5% for 2 years, how much simple interest is paid? So in other words, P is 10,000, R is 5%, P is 2. What formula are we looking at? Oh, this one, simple interest. Okay, so if you, let's see, get out the old calculator. All right, hold on 1 second. I expected to get a few emails from people. I know that this thing was sent out at the last minute. I'll just quickly reply to her and that we'll be back. That's good. All right, I just want to make sure nobody has any issues because of this. All right, so like I said, if you take out the calculator, 10,000 times 0.05 times 2 is 1,000. So with this one, the challenge was knowing that you were being asked to calculate simple interest, which means you have to remind yourself that this is the appropriate formula for simple interest. Okay. Now, this one is not on the formula sheet. It's so basic that you should be able to remember this one. But remember when to use it. That's going to be the challenge. When do I use this thing? Now, on the other hand, how long would a sum of $5,000 need to be deposited in order to earn 1,000 in simple interest? Now, this time we are taking our simple interest formula and rewriting it to solve for time. Okay. That's how you know, because it says how long will the sum need to be deposited. All right, so actually first let's note that the sum is the principal. I is 1,000 and the rate is 5. Okay, actually let me move this down so you can see it all in one place. All right, so therefore T is 1,000 over 5,000 times 0.05. Now, here's where you got to watch it on your calculator. What you're going to need to do is put 1,000. In the denominator, you will need parentheses because you're dividing by an algebraic expression, which has to be solved before the division takes place. Okay, so once you do that, 1,000 divided by open parentheses, 5,000 times 105 equals close equals. Oh, wait a minute. What happened? I think I may have made a typo here. Oh, wait a minute. I know what the problem is. I had this issue once before. I don't think we need this second equal sign. Let me just confirm that. That's better. Okay. Yeah. So I just realized there's one too many equal signs. Okay. And that should give you 4. And this is 4 too, of course. And that means 4 years. So every calculator is, of course, different. I'm more used to the TI-84 series, but let's just say, I wonder if there's a word for that. For if you know 2 languages, you're bilingual. If you know 2 calculators, what would be the right adjective for that? I'd have to look that up somewhere. I don't know if there is such a word. Maybe we should coin it. But yeah, this is how you do it on this calculator. All right, great. So now we have the boxes again. And so these will all be calculations, straight ahead calculations. So let's see, what are we supposed to do here? We have, the future value of the sum. Now, if you notice these, oops, hold on, it's giving me a hard time. Oh, no wonder. Yeah, so I have to be a little careful. I'm using this tablet to write on the screen, which is fine, but sometimes you have to watch it because it can cause issues. And also, one thing I've got to warn you about too, I'm going to send this out as both a PDF and a Word document, because sometimes if you try to open this up now in Mac without it being turned into PDF, sometimes the handwriting doesn't translate well. So I'll send out both versions in case you run into problems trying to open this thing up on a Mac. Oh, well, what are you going to do? All right, I think we're good. Now, first things first, what formula do we need here? Since you see that there's compounding frequencies in here, and there's 2, and there's 4 here, and there's 12, and N is 365. Now, because we're allowing for the possibility of more than just annual compounding, we are going to use the general formula, not the simple interest formula, for calculating our future values. Okay. So now it's just a question of being careful with it. So first, identify the variables. And then now we're going to plug them in, of course, but we certainly want to simplify everything. All right, so that's fine as far as it goes, but it's going to be very difficult to implement that in the calculator. All right, now this isn't too bad. But what I think you should do, as I mentioned before, is go from right to left. But before you do, make sure that equals is in there before you try to multiply. I don't think it'll work without that. All right, let's do this. $11.03. $81. I am going to do an experiment right now. I just want to see what happens if I leave out that equal sign. Oh, okay. Well, it turns out that this equal sign is not absolutely necessary, but you know what? I think just to be on the safe side, there's no issue caused by putting it there. You know, it's like an unnecessary precaution, I guess. It's like, if let's say you run out the door and you're like, oh my God, did I lock the front door? And you go back and see that, of course you did. It's kind of the same thing. There's no harm in double checking. All right. Oh, I'm going to show you an interesting trick here on Word. I don't want to scroll back and forth 100,000 times. So there's a feature here called split. Use split. If you use Word a lot, you'll appreciate this. Okay, what happened? There it is. There it is. So you see what I can do now? I can independently scroll up and down. I can leave this here all the time without having to go back and forth 1,000 times. So for part B, let's do it here. Okay. So first, of course, identify the variables. P equals 5,000. R is 6. N is 4 for quarterly compounding. And T is 5. All right, then. All right, and once again, we'll simplify. And then what you should probably do, although you don't have to, is go from right to left. It's what we're really trying to do here is start with the messiest part of the expression. Whatever this number is in parentheses raised to the 20th power will come out before this equal sign, and then I'm going to simply multiply the result by 5,000. Now for here, I must have 5,000 equals rather. Oops. Of course, the biggest issue, you still have to always keep your eyes open for typo. Because let's face it, these are tiny little buttons. Your fingers are pretty big compared to these buttons. All right, that'll do. Remember, we're rounding to dollars and cents. And, yours could be ever so slightly different, and that's fine if you're off by a penny or two, because it's rounding, just rounding. Actually, let me move this out of the way. Okay, let's get that up there. All right, then, that's fine. That's B. Now C. Principal is 2,000. R is 9%. Compounding monthly, time is 7. And then we'll have let's see. Okay, I've got to be really careful because the R's and N's can start to look alike. Okay, that's better. All right, here we go. 2000. 1 plus 0.09 over 12. Oops, 7. So by the way, 9% divided by 12 is 0.75%, which is 0.0075. You got to be careful with that. And then 7 times 12 is 84. There was 1 plus 0.75%. Now we have 1.0075 raised to the 84th equals times 2000 equals 3746 40. All right. So you can see, I mean, they're all very similar to each other. If you can do one, you can do them all. But again, you really do. It's all about being careful. Now, the next one's going to be a little challenging because n is 365. So we can do this in one or two ways. Let me show you what I mean by that. So over D, E is 4,000. R is 11. N is 365. And T is 10. Now, oh, you'll see what I mean in a second. When you plug these in, $4,000, 1 plus. Here's the problem. 11% over 365, that's going to be a very small number. Now, because we're rounding our results to dollars and cents, you can round that result as well, but we have to be careful not to over round it. So if you type 11.11 divided by 365, ooh, look at that. So I'll tell you what, let's do 1 point. Oh, it's 000 3. That's probably good enough. All right. So now in a second, though, I'm going to show you how to get the exact value out, just in case, let's say you're in a situation where you need all the precision, that it's not good enough to have dollars and cents. I'll show you what you would do differently. Okay. So for this, all right, I'm looking at the correct answer and I'm realizing that we were kind of over rounded it here. We're off by quite a bit. So, I had no idea it was so bad. So let's try this. Let's not round it so much. Let's start again. It's one thing to be off by a couple of pennies. So the original result was 0.11 divided by 365. Yeah. Oh boy. It makes too much of a difference. So let's try this. Let's see how close we're going to get. All right, let's try that instead. 3 zeros, 30137 raised to the 3650 power times, yeah, this is a lot better. 12,000, yeah, now it's exactly correct, by the way, within dollars and cents. So it looks like we can't round too much. I thought we could get away with less, but it was just too far off. I mean, the way we had it before, it was off by almost $50. Now, what if you really need all of the precision? In other words, you cannot be rounding at all. Well, what could you have done differently? So here's what we're going to do. We're going to grab this. And what we're going to actually do is this. Yeah, wait a minute. See, this is so you got to be careful with the all the parentheses. Let me just double check this. Oops, I just forgot. We have to raise this to the 365 power. Equals, and then times 4,000. Oh no, something went wrong. Oh, I know what I made a typo. It's fine. Yeah. Oh, those typos. Oh my God. So you could see what's different here is that it's actually 67 point something cents, whereas up here we got 68. So you can decide for yourself which one of these you'd rather do. But you know, this is such a complicated mess down here, which you might want to do because it's such a tiny number. Just round it. We used 8 places, and you got a very reasonably close answer. I think that'll do it. Okay. So it's just a question of when you've got really, really small numbers. So you just have to have, you just can't round as much. That's all. Just remember that. I mean, up to this point, we've been rounding things to 4 places maybe, but when you get such a small number, maybe increase that to 8, just to be on the safe side. Well, all right then. That is number 2. Now, number 3, we're switching over to an annuity. And it says the words annuity. And that means here, this is the key difference. R, capital R is our repeated or periodic payment. That takes the place of P or principal. Okay. Let's fill these in. And now just be aware. Oh, but you know what I should have done? I'm going to go open up the formula sheet for the midterm. Oh, it's here somewhere. Hold on 1 second. I've got so much stuff open. Just to make sure you realize now, the ones we just did a bunch of them with this one. This is the next one. This is the annuity formula. Yes, and you can tell because it has that capital R there. Also, if you forget, just remember that annuities are clearly more complicated than the future values of a sum. And again, you can see the only real difference between the two of them is R versus P. So I'm going to copy this in here. Okay. All right, the computer's giving me a headache. All right, there we go. Jesus. It gets like this sometimes. All right, so let's do the first one. What the hell? All right, you know what? I must have not noticed that I hit that button by mistake. I almost had blue for the rest of the way. So 500 is the periodic payment. Lowercase r, the interest rate. Now, these rates are annual, by the way. These are always annual numbers, but the compounding frequency is what we use to adjust. And then time is always in years, which is 2. All right, now this one really needs some simplifying. Okay, now once this is done, what you should do is work on what's inside the brackets. Okay, so in other words, 1.02 is raised to the 4th power. And then we subtract 1. So everything you just did here represents what's in the brackets. Now, another thing you can think about doing is doing it in stages. In other words, let's just concentrate on the brackets. All right, 1.02 is raised to the 4th power. Subtract 1. Yes, okay. So I've got 0.08243216. This is what it says in the window, which you can then easily just leave it there, multiply by the 500 equals. If you do that, you'll have the numerator of your expression. And now all you have to do is divide by 0.02. Now, you don't have to write down those intermediate steps. But if you do, and you make a typo, you don't have to start all over again. I don't know about you, but I hate starting all over again. So rounding to dollars and cents is $2,060.80. So let's say you've got to the first 2 parts correctly, and then you accidentally type divided by 0.03 or something. Well, you can at least go back to where you were. It's up to you. You could just do this whole string of calculations if you prefer, and then come to your answer. But this might be a good way to help yourself avoid mistakes since it's such a complicated formula. All right. I'll leave it there for a second for you to catch up. All right, let's go get part B. I'll just copy these, I guess. That's kind of nice. I can't do that on the board, can I? No. All right. So I've got what do you have? When you fill it in, this is what you'll get. All right, so be careful with that. If this part is wrong, of course, the rest of it will be wrong. Now we simplify. And so as always, I think our best bet is to do the brackets first. Oh, it would help if we had the 10 there. All right, 1.03 to the 10th. -1. It's about, and again, you don't have to be writing every single digit down because it's still in the calculator's memory. It's approximately what you're seeing here. And then we need to multiply by the 1,000 to give us the numerator. And when you're done here, you'll have the entire numerator. 343. $916,379. And then we divide it by 0.03. Equals. And it's going to be 11,463.88. All right. So that wasn't too bad. All right, give me a minute to catch up. All right, Next, C. Well, I don't know why it did that. Okay, here comes C. All right. Actually, yeah, think about it. I might as well save a little writing here by just copying and pasting. There we go. Oh, yeah. Now, this is one of the annoying features of this pen. There's a little button on the side. I can't, if I punch it by mistake, it makes a mess. I don't understand why this is even on this thing, but you know, you don't ask questions about technology. They just do what they want to do, whether people like it or not. It's too messy. Hold on. All right, so that's the simplification. So we can now work on that. We'll start with the brackets. So 1.2 to the 32nd power. Minus 1 is about 0.88. 45. 4059. About. Then we multiply by 2000. $1769. 08. 118, let's say. And then we can just divide by the 0.02 and we'll have our final answer. $88,000. Now this one we should round to dollars and cents. 454.06. Okay, and that's it. We're done. All right, let me give you a minute to catch up. All right, so now we're ready for D. All right, let's try this last one and then we can move on to something different. Okay. Oh, I forgot. I can just copy this. How convenient. All right, so we're gonna have 1,000. 1 plus 12 over 4. Now here we've got to watch it because we had this bad experience before where we over rounded. Unfortunately, 12% divided by 4 is going to give us. Oh, wait a minute. Nope, sorry, I was thinking of the wrong one. Sorry, no, never mind. This will be perfect. It's just 0.03. No, it's just sometimes when you divide by certain numbers, you might get a lot of zeros. Not this time. All right. False alarm. We're good. All right, good. I love this undo button. If only we had an undo button in life. You know, how cool would that be? Okay, so 1.03 raised to the 40th. Oops. All right, so that's going to be about 2.262. 03779. All right, times 1,000. Equals 26. No, 22. 62. Actually, I'm going to move it over here to be consistent with what I've been doing. 2262.03779. And now finally we divide by the 0.03. Ooh, sorry. Oh, sorry. It would help if I had the division. Oh, sorry. Oh, I just noticed there's a chat. I hope that hasn't been sitting there all day. Jason, you're here. All right. Yes, I expected some. If you didn't notice the message right away, I could see why you might be late. It's fine. If you missed anything, by the way, this is being recorded. You can watch it. Okay, good. Yeah, you can go back and watch the recording if you started late. It's okay. Yes, I expect there to be a little bit of confusion on this. So I'm glad you told me though. The full list is right here. So I can see that you're all here. I hope nobody went to the room by mistake, but I wasn't sure until pretty late yesterday that this just wasn't going to happen. So all right, anyway, let me just finish this up. Oh yeah, so there is a chat room here. It shows up with a little red one. I think it pops up as soon as you type in a message so that I can't miss it. But if you were sitting there for any length of time, I apologize. I just noticed it right that second. All right, anyway, so let's finally divide by 0.03. And we'll get our final answer, which is about 75,000. And again, this part you can just simply round to dollars and cents. The rest of these, you want to keep as much accuracy as you can, but this one really only does need dollars and cents. The bank is not going to pay you a fractional cent. Because even if they wanted to, it's not possible. How would they do that? Can you imagine somebody sending you a check for $500 and 13.7 cents? I wonder how the bank would react to that. Oh, they'd probably just round it, but there used to be in the United States a half-cent coin, but this is in the mid 1800s when a half a cent was still worth a fair amount of money. But yes, we've had coins as small as half a cent. Obviously, they're gone now. I don't think we've ever had anything smaller. Okay, anyway, let's get on. Now, we're ready for 4. Now, 4 is what we were alluding to earlier. That question about compounding. What you've got here is a bunch of these are actually EARs that we're looking for, but this rate, even though it's labeled R, actually is the APR. So the formula, let's go back to the formula sheet and make sure you know that it's this one. And just make sure you remember, in this formula, E is clearly ER. The R is not so obvious. This is the APR. Okay. Now, N is very simply the compounding frequency. That hasn't changed. And so in this chart, you can see N is 2, 2, 4, and 4. All right, so this is what you, like I said, when you go to a bank and you see 2 numbers on the bank accounts, this is what's happening. For number 1, for A, for example, we're being told that R is 4% and N is 2. And that's all you need, 4% per year, twice a year. The number of years doesn't matter for this calculation. You notice the T is missing. So E would simply be 1 plus 0.04 over 2 to the second power minus 1. So as usual, we'll simplify it. And since it's such a simple formula, we don't have to change the order. You can very easily just write 1.02. Now here you can use the square button, or I just tend to use the exponent number, the general exponent function, just because I'm so used to it. But remember, there is a square button on this calculator, which you can use instead of raising this to the second power. But either way, you're going to get 0.0404. Which is 4.04%. And I just want to point out, although it doesn't specifically ask you for this. No, that's all. It just wants that. But just as a quick reminder, 4% is the simple interest. The remaining 0.04% is the compound interest. Okay, that's what that's all about. So in other words, the last 0.04% is the result of having semi-annual compounding. If it had been annual, then there'd be no compound interest at all. So you can say thank you to the bank. If you're the lender, if you're the borrower, you say no thanks, you're charging me more interest to borrow. Okay. All right. So let's just quickly run through these 2. Sweet. Oh, for God's sake. All right. So again, all you need is 2 things, R and N. All right. So steal this formula. So this simplifies very nicely to 1.03 squared. And so you can just simply do what you did here. And you can optionally just use the square button. Okay. And you're going to get 0.0609. And again, even though they didn't ask, I know. Let's do this anyway, just so you fully understand what we're doing. All right, so the 6% is the interest on the principal, the simple interest, the rest is the consequence of having semi-annual compounding. Okay. Let's just leave it there for a minute. All righty, now part C. In part C, we're being told that R is 8%. That's the APR, of course. And we have quarterly compounding. So once again, we'll steal this formula. And when you simplify that, we have 1.02 to the fourth power minus 1. Okay, so that's going to be you can round this, by the way. This is a fairly long number. 0824, that's fine. Normally, interest rates, when you see them in the bank, they're only going to show the first two numbers after the decimal point anyway. So if you walked in the bank here, you would see 8% is your APR or simple interest, and 8.24 would be your EAR. But we know that that's because that last 0.24% is our compound interest. All right, and then D. In part D, it's R is 12, APR that is, and it's quarterly compounding. All right, we'll just steal this formula. All right, here we go. 1.03 to the fourth equals minus 1. All right, so it's approximately 12.55%. Of which, of course, as we can tell, 12% is our simple interest, and the remaining 0.55% is our compound interest. All right. So you can see too, if you notice, as the simple interest gets larger, the compound interest also gets larger. In the beginning, the difference was pretty trivial, like 4 versus 4.04. But when you start getting up around 12, it starts to matter a great deal how frequently it's compounding. Now we have a handful of word problems here. And so again, as always, the big issue is how do you interpret it? Okay, so let's take a look at this one. So we have William, he's borrowing $10,000, which is clearly principal. He's financing his senior year at SUNY Purchase. He's majoring in the history of underwater filmmaking. Oh, I like that idea. The loan is repaid in 5 years. That's T is 5. And the simple interest is $2,500. Now, as soon as you see that, you know that this formula is somehow involved, okay? Now, here they want to know what R is. You're going to take that and rearrange it algebraically. Okay, so starting with I equals PRT, R equals I over PT, which equals 2,500 over 10,000 times 5. And so using your calculator, make sure that in the denominator you have parentheses. Also, even though I'm writing it with commas, the calculator will not accept commas. Okay, so okay, that should do it. 2,500 divided. Oh, it puts in the commas, but if you try to type them, I don't think it'll like that. Just type the number as it is. And don't forget the equal sign at the end there. And this means 5%. So that information implies that William is paying 5% for his loan. Okay. So that's how you know. If you notice too, there's no mention of compounding frequency because we're talking about simple interest and it's irrelevant. Okay. Now, it looks like there's a couple more. Now, I have to admit, I thought this was going to take longer than it did. So you know what we're going to do here? I would like to at least take a quick peek at the next chapter just because we have a little time here that we don't want to waste. And so when we're done with these next 2 questions, I'm going to open up chapter 11. And 11 is very, very different than what we've been doing, but it's really interesting. And there's a lot of excellent videos that we'll be watching to help us understand these concepts. It's just the kind of subject matter that lends itself very well to videos. You know, some of this math, yes and no. I mean, some of them can be turned into exciting videos and some of them not so much. Anyway, so here's Cynthia borrowing money for 5 years to buy a car. The rate is 5%. So this is something you'll probably all experience one day. And the simple interest, again, 5,200. So we'll start with this formula. What we're looking for is how much did she borrow, which means we're looking for P, the principal. So in other words, how much must she have borrowed for these conditions to be true? So therefore, starting with I equal PRT, that means that P must equal I over RT. Okay. So we have, okay, 5,200 divided by the product of 0.05 and 5. So again, be careful here. When you divide, do not forget those parentheses. Because otherwise, you'll come up with a completely wrong answer. I mean, it won't even be close to correct. $20,800. So that indicates that she would have borrowed $20,800. Okay. One more. Now, this is an interesting one. A student has decided to become an entrepreneur. He's going to run his own business on campus and make lots of money. And how's he doing this? So Ralph is starting up a new business selling smoothies. Now, who doesn't love smoothies? But he wants to have ones that are unique. You're not going to get anywhere else. So he says that his best sellers are peanut butter and jelly smoothies, avocado and anchovy smoothies, and horseradish and honey smoothies. Don't those sound good? Actually, the peanut butter and jelly might not be that appalling, but these other two, I think you would not probably enjoy them very much. But if it works, you know what? You don't question the customer's tastes. Okay, that's not what business is all about. You give people what they ask for. Okay, end of story. So to run this business, Ralph is borrowing $100,000. The rate is 7%. And the interest, simple interest, is $35,000. So how long did he borrow the money for? This is, notice they want to know how long the loan is for. So I equals PRT, which implies that T equals I over PR, or 35,000 divided by 100,000 times 0.07. And so on the calculator, $35,000 divided by open parentheses 100,000 times 0.07 close equals. All right, here we go. Okay, that works out to 5, which means, of course, 5 years. Okay, so Ralph took out a 5-year loan. And so here he is out in the lawn there selling smoothies to everyone who walks by. And I guess he's making some good money. People are flocking to his table there to buy his peanut butter and jelly smoothies. All right, so that's done. So we're ready to roll, but you know what? Since we've already talked about having the test next week, let's just do it. Let's not speed it up. We'll save it for a week from Thursday. You'll have plenty of time to study. So in the meantime, we'll just get back into the new material, which, like I said, is very, very different than what we're used to. The two chapters 11 and 12 are probability and statistics, which is an incredibly important area of math because every discipline uses it. Some aspects of math are more narrowly focused on certain areas. Some areas are used everywhere. There's almost no discipline you can imagine that doesn't at some level use statistics. So it's important to understand at least the basic concepts, but I think you'll also find it to be quite interesting. But anyway, this is done. I'll post this later on. In the meantime, let me go into my archives here and find chapter 11, so we can at least see what it's all about. I think you'll find the videos in this section to be really interesting. Here we go. All right. Okay. So this one, actually, your calculator can come in handy. There's some functions that I'll be introducing you here. You might not have even noticed were on your calculator. So I think you'll find that to be quite interesting too. It was always fun to learn more about your calculator. Okay, so we're going to start our discussion about probability theory with believe it or not, counting. Now you might say to yourself, well, I know how to count. What is this all about? But no, actually, we're going to be counting very interesting types of concepts. In other words, we're going to be looking at very specialized circumstances where we want to know how many different ways there are to accomplish a task. So let's start with the basic concept here of the fundamental counting principle, which refers to the number of ways in which a collection of objects can be arranged. Now, the classic example of this, I like to use this as one of my favorite examples, is posters. So for example, let me just throw an example in here, and then we'll go on to the next one. Suppose that you have exactly enough room on your wall to hang 3 posters. Okay, so from left to right, your wall space has exactly enough space that you can hang precisely 3 posters. We'll just call them posters 1, 2, and 3. It could be anything, like it could be, it could be the Mona Lisa, and it could be the Yankees, and it could be, your favorite band, and it could be anything. So the question is, how many different ways can you hang your posters from left to right? In other words, this is just one way I can hang my posters. What else could we do? Suppose it's the first day you're moving back into your room and you're like, well, wait a minute, what can I do with my posters? Well, I could do 1, 2, 3, but it could also get crazy and do 1, 2, 3, 2. 2, 1, 3, 2, 3, 1, and then finally 3, 1, 2, and lastly 3, 2, 1. That covers them all, right? It does, yes. There's no other way of hanging these posters. So it turns out there's 6 ways of hanging the posters. Now, if you notice, though, we did that just by writing them all out. Okay, that's very inefficient. There are 6 ways to hang these posters. Each way of hanging the posters is known formally as an arrangement. Okay, so we're taking a group of objects or numbers and simply changing the order. They are known as arrangements. Now, suppose, though, that we wanted to figure this out without just writing them all out. Okay. How can we determine, without counting them all, that there are 6 ways of hanging the posters? Well, here's the logic behind it. For the first slot, I guess, the first poster, we can make the case that there are 3 choices for the first poster, since none have been taken yet. But once we choose the first poster, there are 2 choices for the second poster because one of them has already been taken. And if that's the case, there's only 1 choice because there's only 1 left. Or the last poster, or the third poster. Okay, since only 1 is left. So the logic here is that the number of ways to hang these posters is the product of these three numbers. Therefore, the number of ways of hanging three posters is simply 3 times 2 times 1, which is 6. Okay. Well, that wasn't so bad. And that also indicates that if instead you had room for 4 posters, the number of ways of hanging them would be, and based on the same logic, it would be 4 times 3 times 2 times 1, which is 24. Because you'd have 4 choices for the first poster, 3 for the second, 2 for the third, and 1 for the last one, 24. Okay. Now, this is an important detail because this means we can, in principle, figure out how many ways of hanging any number of posters. But you might object to wanting to write out all these products. In other words, if it was 6 or 7 or 8, that starts to get very cumbersome. So it turns out there is a mathematical operator that can take care of this for us. And this is on your calculator, by the way. And so it's written like this: n with an exclamation point is pronounced n factorial. Okay. And so this operator will do exactly what we need to come up with a number of arrangements. Okay. So on your calculator, you'll find it. Now the calculator is labeled as x factorial, by the way. If you go to the extreme bottom left-hand corner, you'll find it there. So let me just show you how this thing works. N factorial is only defined for non-negative integers as follows. Okay, so 0 factorial is just 1, 1 factorial is 1, but then 2 factorial is 2 times 1, which is 2. 3 factorial is 3 times 2 times 1, which is 6, just like the posters. 4 factorial is 4 times 3 times 2 times 1, which is 24. 5 factorial is, 5 times 4 times 3 times 2 times 1, 20, etc., etc. So let's do a little practice with it. Let's prove that 5 factorial is 120. What you're going to do in your calculator is simply type 5 followed by that x factorial sign, and you'll get your result. You do not need equals with this one. On the calculator. By the way, if you're using the Texas Instruments series, it's a little bit more complicated than this. Okay. Let me just quickly sketch in the steps for the TI-84 in case that's what you're using. So just type 5, and then I usually like to put a little box here. Yeah, without the equal sign. On the TI-84, you would do the following. You would type the 5 first. Now you have to go through some menus here. And so what you're going to do is hit 5 math Oops, hold on. 5 math. Then you have to scroll over to the probability submenu. And then you would scroll down to number 4. Okay, 4 is the X, it's right there. And you hit 4, enter twice. And you'd be all set. All right, it should come back with your 120. All right, so it's a little bit more cumbersome, but it works. Okay, so that's the mysterious factorial operator. It is designed to tell us how many ways there are to arrange n objects. All right, so anyway, so I think we'll pick that up when we get back. I just wanted to introduce you to this idea, and then we'll start from there on Thursday. And then, of course, like I said, the following Thursday we'll have the test. But in the meantime, we're just going to spend the rest of our semester going through 11 and 12 and getting ready for the final exam in early May. All right, so I hope that was not too strange of an experience doing it online. I mean, like I said, a couple of years ago, every one of the classes was online because of COVID. So it was kind of strange. Now, you know, once in a while, it's okay because, you know, things can happen, but it's good to know that we have the ability to do this. So, all right, I'll see you in person then on Thursday. Okay. All right. See you later.
Thank you. Have a nice day.
All right. Bye.